what we should all be happy with is we're getting to know and love our properties of cis theta. So when we've got h, everybody was happy that we'd go this divided by this. And then it would be cis pi on 8, take minus, so take becomes a plus, that's okay. But people were asking, I had several people asking about I. So those who did it, oh, when did you sneak in? I have to go and change the role now. Did you sign in? You should have. All right. Shh. So, to be honest, with I look at that and go, ooh, because those of you who have looked at 4e, Tues theorem, you might be going, this is quite a nice thing to do. But at this point in time, what you would be doing is you'd say this is root 2 cis pi on 8 times root 2 cis pi on 8 times root 2 cis pi on 8 times root 2 cis pi on 8. And what happens now? Root 2 times root 2 times root 2 times root 2. We end up root 2 to the power of 4. And cis times cis times cis times cis, this becomes cis pi on 8 plus pi on 8 4 times, which is in effect cis 4 lots of pi on 8, yes? And this is a really great intro into what we're actually doing with 4e, which is a theorem that they came up with, a pattern which summarizes this. Oui? So, is that okay for whoever was asking about I? I've forgotten, I just had the request down there. So, if you hang on to your hats for a little bit and we now scooch on, and don't worry, I am coming back to the other questions, but it's a great intro. Couldn't have orchestrated that better myself into Tues theorem, right? So it shouldn't come as a massive surprise to us after that question that some smart cookie back in the mathematical ages came up with this as a summary. And would you agree that is exactly what we've done with this question, right? Because it became root 2 to the power of 4. That's what they're saying here. Yeah, oh, and Will snuck in. And what happened to it with the angle? Oops. It's multiplied. So we go, ah! If only we knew this back then, right? So sometimes when you go through and you do that question, I confuse the pants off kids because I just go bang. They go, what? What are you doing? It's like, oh, sorry, we don't know this rule yet. Now we do. There is something that we always have to remember, though, about our angle. And what is that? Right, it has to be between, and we'll get fancy now, less than or equal to pi, but greater than minus pi. Okay? No, because obviously not equal to, because obviously minus pi is pi. So we'd prefer to have positive pi rather than minus pi. Okay? So a lot of this stuff now is very straightforward once again, where you're just going to go, oh, that's going to be root 2 to the 10. This is going to be 10 times pi over 5. But your biggest dilemma is to go, hang on, this can't be more than pi or minus pi. Okay, has anyone come up with a system of how you get rid of? Yeah? Yeah, you just subtract multiples of 2 pi. or add if it's more than negative pi, just add on 2 pi. What are you going to do with question 3? Put it into what's polar form first. And how do we put it into polar form? Sure, you could find the modulus using Pythagoras. You could use your tan thing to find the angle, or use your calculator. Okay? Are we all happy of how we use our calculator? If you're not, I'll come around and assist. So, a lot of that stuff is just going onward. So if you don't have any other questions, by all means, continue on. I've got a worksheet that I'm just finishing off a question. I had it all nice and I thought, oh no, I came up with a good question, so I've added that. So that's coming towards you soon. Question 2, this one, use the property of that, which is your shortcut basically to evaluate. So what can we do for these, Moses? Oh, he's flicking back because he did it. Love it, love it, love it. Yes, Will? Yep. Which would be, so, would we agree it's 8 times 2 pi plus pi? And so that means that bit there is basically kaput. So this becomes the same as cis pi. And again, you can use your calculator, or would you like to visualize this? So where is cis pi? Wouldn't it be right here? What's its modulus? 1. So in effect, this is what's on your real. What would it be? -1. Yep. Sorry, I know you might be saying something, but I can't hear through the mask sometimes. Oui? Okay, what about this one? What would that be? -18. I'd probably go 19, yeah, because then you're above. -19 times pi, so that becomes -38 pi, and then we're taking pi, or should we add pi? Doesn't really matter. We add pi, of course, sorry. And so again, that's going to be -1, 2. Do we get the gist? All right, going well. Thanks. So question 5 from 4C3, which was a request, is an induction. So I think it's a good opportunity to go back and just remind ourselves about the process of induction. And we left out question 7 from right at the beginning, I want to say. B1? B1? So remember, we have our statement. This is the thing that we want to prove for certain values of n. We then prove, and I've written p of 1 here, but remember it could sometimes be p of 0, it could be p of 2, depending on what value for n they're saying. So we write that, we prove it. We have to go left-hand side equals right-hand side, and you must actually write that statement. Therefore, p of 1 is true. Has to be there. Then we write our p of k. And we assume that it is true, correct? And then the whole deal is we want to prove pk plus 1, and you must say using pk in that process. Do you remember this fondly? All right, let's give it a crack. Do you actually need to write that down, or it's embedded in your brain? They said embedded. Excellent. All right, so prove by mathematical induction, for all complex numbers. So that's one of our properties as well. All right, so are we happy that this is our, so we better write Pn Z1, Z2, all the way up to Zn equals Z1 times modulus of Z2, all the way up to Zn. Okay, we've got n positive integers. Agreed? All right, I feel the rainbow coming on today. So the first thing we're going to do, positive integers, that's mean we're looking at P1. So the left-hand side, well, that's just going to be Z1. Right, stops right there, the first term, correct? And the right-hand side, if we're looking there, that's our first term there. So, hello, that is also the modulus of Z1, so it equals the left-hand side. Therefore, P of 1 is true. Okay, so the most difficult thing thus far has been to not get bored writing all of that down, because no mathematics really has been done. All we've done is we've said assume PK is true. So thanks to ETH, we've written that down and we didn't put the N there, we put the K, which is what I suffer from sometimes when I haven't done induction for a while. So that's what we want to prove. That's what we're assuming. And then to prove, remember, I think it's really easy, makes your life easy if you include the kth term and then the K plus first term. Okay? So that's what we want to prove to be true. And we have to use this statement here. Well, this statement here. And how are we meant to do that? Well, we actually do have a property, right, that says Z, did they use Z1 and Z2 or Z and W? Oh, I've got to scroll back. Your properties of modulus. Okay, we've got this one. So the fact that we have, I'll put that underneath. My board's had a long weekend. We're actually going to basically call this, I can't say Z1 because I've already got Z1 there. So shall we call this W1, right? And this is basically your W2. And so using our modulus property, that W1 modulus times, the modulus of W1 times W2 equals, what we can now do is separate this and say, well, this becomes Z1 times Z2 times all the way up to Zn times Z K plus 1. Do we agree? Yes, I did it again. Zk up to Zk plus 1. Can we see that up the back? Right, using, thank you, Bobby, go, yeah?
Use like Z1, Z2 to the Zk.
Yep, isn't that?
And then,
isn't that this? Yeah. And what are we saying that equals? Well, we're saying that equals the separate bits there. So now that becomes Z1 times Z2 all the way up to, yes, Zk. Right, that's that bit. But then we were also saying times by Zk plus 1. And correct me if I'm wrong, but that is the right-hand side. What have I forgotten to put? Good. That's what told us to do it in the first place, right? Using P of K plus 1. And using PK. No, don't be sorry. Bobby says he's sorry. Using PK. Lovely. So therefore, what colour haven't I used? Oh, blue. Therefore, PK plus 1 is true now. Who wants to embrace it? Who's going to stand up and say it with hand on heart?
no, wait, no, you do it.
Since P1. Shh. Now, please remember, this isn't you memorizing I hope, the statement. It is you summarizing the process that you've done. What did we do? We started with, since P1 is true and PK plus 1 is true whenever PK is true. Well done. Then P of N is true for N by P M I. Huzzah! So just jump now. 4E question 6 was the other request. They've asked for real. That was part A, and then part B was purely imaginary. Right, and we're talking about polar form here. So when we've got this, what part of this will be? Let's start with, we'll go purely, it's a bit silly to say purely real, but if it's real, isn't it just this part here? So what does that mean for I sine theta? It has to be? Right, so for it to be real, I sine theta must be 0. Now think about for what values will sine theta be 0? When is sine 0? I'm a graphy person. Some of you might be the unit circle people. When is sine 0? Here and here. So what are those values? 0, pi, 2 pi, basically multiples of pi. So think about that when you come to this question, and then clearly when we've got something as purely imaginary, what does that mean? That means cos theta has to be 0, and this has got, I think there's n's in here somewhere, so you've got cos n theta or whatever, yeah? So think about that. If you're still stuck, I'll come around and have a play.